And so we've got the software running from the start. And I've just put this in the background in case we need to look at. So as I started yesterday, we're just going to be framing the building in line with assignment 1. Right? So this is just a new file. I'll just open the software from the start. First thing we said we're going to do is to define the number of levels. That's we go to the input, we go to the story heights, and the way I would do it is first thing I want to call this level to be ground. There are different ways to do it. Then after I define the very lower level as ground, like the soil level, I'll just add above it 10 floors. And now you can see you've got the ground, then 10 concrete floors, then the roof. Just do it same as what you did with your assignment, or the way you submitted your assignment. Then we can hit OK. And the system now should know the number of floors you have for your development. Okay. Now what I'm gonna do is to bring in the CAD drawings. So I just go to the Home tab, click on the CAD, click on this little CAD again, and then click on the little arrow, then click Load, which I'm doing. Then I go to the typical floor of email I've shared with you yesterday. And now the RCB is reading the file. So yeah, we got it on. Just click OK. So we're gonna move CAD file to the origin. I think now, yeah, yesterday we said we're gonna do the master and slave. We can do it after, but fortunately, I've got it on the level 1. So it's good practice to bring the CAD to level 1, and that was there already. So we are okay. I'll just click OK in terms of bringing the CAD to the origin, and now we're okay. The CAD was brought to level 1, which is what I want to do. See, if we go to level 2, you won't see it there. So it's level 1. And one thing we're supposed to be doing is defining master and slave. So whatever you draw on the master, you're going to go to the slave. To do that, again, go to the input, click on this option, or this tool, then you're going to have this window opened. Click New Master Slave Group. The table will be activated as shown. Select level 1 as the master. Then you can see there is M there. Then it's asking you now to select the slave levels, and I would say I'm going to be selecting everything apart from the ground, because I don't want to define columns and slabs for the ground. So that's what I'm doing, and I'll just say apply. So all done now. It's blue, and we can say exit. So that's now ready. So everything we're going to draw on level 1 going to be applied to level 2 and above. All right. So I'm assuming you are progressing with me. Now what I'm going to be doing, just putting my walls. As I said, I'm just going to follow the scheme. In my example, I'm just going to use 200 thick wall for everything. But in your case, you can use 150 for the green and whatever thickness you had for the core. So let's go to the and what I said to you in my CAD, I've introduced some little purple lines to define where is the center of the wall. You can adjust that as required for your case. So to define the walls, you just go click on home, click on the wall option, and then define the thickness. I'm going to define it 200, so it's 0.2 of a meter. Let's go with using pin top and pin top portal because we won't do moment connection. Then by now I'm ready to draw the wall, but before that, try to snap through the CAD. So you have to activate the CAD. And now if you zoom in a bit, it will trigger the CAD object. So now I'm putting my walls and I'm just going to go through the walls. So yesterday I was not using a mouse. It was a bit slow, so you can do this as well. I'm just doing it. I think you can see that's the advantage of having that purple line. It's just going to help me to stop here and then to start there. If you don't have it on the CAD, it won't be. See, I made a mistake here. You can just simply select escape, then select the wall and delete it, and go back and put it. Just again, click wall. You have the thickness set already and whatever other options, and then I'm just going to go again and finish it. So maybe in 1 minute, I will finish that. I don't need to define this little thing. It won't really help whether you define it or not. These little walls like this part and that part. It's up to you if you want to do it. You can define this little purple line here and also add these ends, but in fact, it won't really make a huge impact on your design. So, and that's the last, I think that's the last external wall. So all my external walls are drawn. Let me have a look. I have another green wall here and a green wall there and there and there. So I'll just put them. I've got this wall here. And there was another wall there. I see I've made also a mistake here. So I'll just go back to, there is an option also to drag it. And drag it to fix itself. So that's the other wall. And there was a wall here as well. So I'm sure each of you are going to have different ways to drive and use the software. Yeah, so I'm done with the internal walls as well as external walls, and now I'm just going to define a core wall, which in your case you will have your own special thickness. And so in my case I used the 200 thick. So at this stage I'm done with all my walls. There is a little column here. Simply just hit on column and put the dimensions as given for you. It was a point, whatever did we specify here? It was 200 by 1 meter. So say 200 by a meter. Yeah, I put it here, which is old. I'll just put it here now. Yeah, if someone's going to say, how can I define the location? You can use the CAD. You can go to the CAD I've given you and just add another center. You can still like move it slightly to the left or right. You want to get it in the accurate position. So if I say 24th, so it's moved a lot up, but it's not that much. So it is 23.7 to bring it back to where it was. So you want to exactly locate it where it is. Let's say here another. Yeah, it's very good. Location. But to do it to the last millimeter, you kind of update it in the CAD. But here it's okay because it's not hidden. It's not extended to the void. It's just within the right spot. So it will definitely do the job it's supposed to be doing. And this column, I should delete it away. Just select it, and with delete, it will go. So yeah, all the vertical elements should be defined at the stage, and we can have a quick look to click on tools. Always is good to look at the 3D and just to make sure everything is kind of making sense. Now, what we can see here is the vertical elements. You can see at the ground floor, we don't have nothing. We will copy it later. We will copy the columns, the walls, and that one column to go to the ground floor as well. Why I didn't add it as a slide, because now when I'm going to draw the slab's going to be placed from the roof all the way to the first floor. I don't want to put it for the ground and then delete it, but it's up to you. You can still do it if you wish. So for now, what I'm going to do, before I copy there is a way where we can easily copy the walls only to the ground. I will do that later. But for now, I will just put the slabs, right? So you can zoom in and have a look to what we did, just to make sure there was not a major error in your model. So I can close this window. Now let's put the slab. With the slab, again, go to the home, click on the slab, and make sure, again, your CAD snipping is ready. And then the slab, simply go to the corners of your CAD, and keep going around. Try to list the voids, the external voids, which is I'm doing. So unfortunately, if you made an error here, unless you find a way to deal with it, if you find that made an error, you have to do it from the start. Like if I misclicked another point, I will just skip and see the wall here is a little bit going out. It won't matter. I don't think there's maybe about 10, 20 mil. The wall is going up. You can adjust it. You can select the wall and shift it down. But it won't really affect your calculations because the wall is just defining a point of support. But I can see here the wall has gone a little bit above. The reason is because I've chosen my wall to be 200 thick, while in your case, you're going to choose it as 150. We're going to choose it as 150, so you should not have this problem. Your wall should not be extending few millimeters outside the building lines. So basically, I'm just going around the slab. And as I said to you yesterday, when I'm almost there to the end, I strongly suggest you to make sure that, let's say I'm almost done. I got one click to do. So here I got one click to do. I suggest you to use the right click here and just say close. So it will 100% close your slab. And now if you go to tools, 3D view, you will be able to see it. See the slabs are kind of drawn for all the levels. Right? Now, again, I will have a question asking me what we're going to do for the voids, like especially for the core voids. This is our main topic here. And there is also other voids in the building. We will define a slab, another slab, and we will give them a thickness of 0. The thickness is going to be 0, and then we're going to go. So what we do while I'm still at the slabs, we're going to click slab. Remember, at this stage, we did not define any thicknesses. We just drawn there is a piece of slab. Later on, we will define thicknesses. Right? So for now, we click on the slab again. Right? It's not asking us for any thickness, so we don't need to worry about it. I'm just going to draw another void here, which is, and then right click, close. So I did draw another slab, another one there for the stairs. Right click, close. Then I have another void here. Right, close. There is another void here. Done. Third one, third void. These voids are for services. Close. And I'm done. Yeah, I'm done with all the voids. Now, even if you go, there's a one here as well. Close. So even now, if I go to the 3D view tool, it won't show me the void because we did not tell the software. There is a slab kind of, but we didn't tell the software which one is 0 and which one is with the thickness. So at this stage, it's still not allowing us to import any thickness. We will be able to import thickness after meshing the slab. So we have to mesh the slab, and as we mesh the slab, we kind of define it as a structure element to the software. So we need to mesh the slab. I'll show you how. Then we will be able to define thicknesses, and then the voids will be viewable. That's one thing. And what you can see, these kind of definitions, the column elements, the vertical elements, the wall elements, and the slabs, they are also defined for all the other floors. Right? They are also defined for other floors. While we're here, let's copy the columns down to the ground. Copy the columns. What we can do, there are different ways, but the way I would use here, first I will select all the columns and all the vertical elements, the walls and that one column. What we do here, we go to home, and after you click on home, there is select option. You click select by type. So if you click on it, say I want to select all walls. Right, and also select all columns. So now we can see the green, the blue one, they are the columns, and the walls, then say exit. So what did this tool did for us? It just selected all the columns we got on this floor and the walls. We have only one column, which is here, and the walls. I'll do it again. I'll just escape. What I want to select at level 1. Remember, you should be at level 1. You have to select all the walls and that one column. You can do by shifting one by one, but in order not to miss nothing, go to the home and use this tool here, select by type. Then first select all the walls, say all walls. So select it, all good. Then go to all columns, say all columns. That's it. That single column is selected, and just now click exit because it's already all selected. Then we can go to edit and copy. Click copy. Don't click move. You have to click copy. So after you hit copy, say to another floor. Right, copy to another floor, and now it's going to give you this option: copy to levels. We will select ground. Copy to one floor below. We have to select copy to one floor below. Now we're not able to take these away because they were the slaves. They were just saying you want to what you can do as an option. You don't need to select actually the ground, because you know you are at level 1, and what you can do is say copy to one level below. That's it. It will just take those walls and that column you selected to the one level below, which is the ground. So say as you selected it, it will now select ground. Now they did not. They selected those other levels above because they are the slaves for the master. We're just going to select them by default. So basically, in your case, just select. You have two options: either you tick the ground, or just say copy to one level below, then hit OK. And now you go down, you can see only the columns are copied, right? Only the columns are copied. And if you go back to your reading here, you get to see the columns now. Yeah, you can see your walls are only there, and always good to check this coming down. All right. Right. So we're done with copying the columns. Maybe something else we can do so now go to grounded door, you can see the walls. Select everything here. Select all your columns. Let's because it's confused now between the column and the wall. So let's select, go to home and select only the walls first. Okay. And what I suggest you to do, say for the footing option, say yes, they got a footing. So exit this and say the footing, yes. So we just define there is a footing for those columns. And it won't matter in our modeling for what we're doing in this exercise. I don't want to change the design of the footing. I just want to tell the system that's the end of the wall. It's got a footing. Same thing here. I will just select yes. Remember, we just want to look at the dynamic behavior mostly here. And we will only be interested at the stresses we're going to get in the walls at ground level. So we will not make any setups for the full design. So it won't matter. I'm just going to tell to the software that the wall's going to end there. And if you go now to your tools, click the 3D view and zoom in, you will, it's kind of do that now and define with kind of a strip footing at the end. And if you want to find the stresses on the soil, if your problem is to do with the soil, then you can adjust the size of the footing and the depth and define correctly the soil properties as well. But we're not doing this in this exercise. So you can see that the building is kind of complete in terms of the main element. We just want to define the thickness of the slab. As I said to you, this will be doable after we mesh the slab. So let's do it now. You can see it. And after that, I will put for you the loadings when we talk about the loadings. So I'm going, doesn't matter which level I'm going to go to mesh the slabs. You just go to solve and click on mesh. Now it's for your exercise, I think anything below 0.5 meter will be accurate enough. You know, the meshing is all about trial and error. Ideally, in real practice, we keep meshing as low as it will give you accurate results. Engineers maybe starts with one meter is a quite large mesh, but you can still do it. Then what you do, you can go after you find the results for 1 meter, you can go and find the results for 0.75, then 0.5. If the results are not changing, that means the mesh is accurate. You don't need to do, if you start with 2, then you wait to 1, and you start finding some differences with the deflections or answers, then that means they are not really accurate. Sometimes large mesh can be accurate, depends on how large is your development. Right, so for this exercise, I will go with 1, but you can evaluate it with less, but it's going to cost you more time to do the calculations. So I've chosen 1. Don't need to update now, and I just say go. Okay, now typically it's going to come up with some warning messages. This is to do with the accuracy of defining the line. Sometimes they're going to find that your slab line is not exactly in the end of the wall. This is just warning. It's still acceptable, and the software can close those gaps for you. There are ways for the software to close the gap. Here they're talking about some accuracy. There are decimals. Now there is way for this software to fix it, and I'll show you from where to fix as well later on. Now let's see if it's going to solve it regardless. Just giving you warning. However, there is a way I will show you to help with that warning. But if you try it without solving the warning and you try it with solving the warning, typically it won't change much with the results. So see, it's talking about some gaps in the notes, but I will show you how to fix it. There is a tool under the tools here, which will let you close those gaps by the software. If they found there is a gap between the support and the slab, they will close it for you. But ideally, if you try the results with and without doing this, it won't even make so it's only 1 year on each course, it's not a big deal, and it's to do with the gaps. You can see here, it is just to do with the gaps, but the floor was successfully meshed. I will exit this. So yeah, it looks not bad. There are some gapping issues, you see, because here we stopped where we started. At the end of the day, the slab will be supported on something, so I don't need to worry. If there is a little gap here, nothing going to happen. So how to fix those gaps issues? Go to tools, and you can see here, fix closed nodes. You can do it from here. You can do it later. So I suggest you to keep trying, do it, and look at the results. It won't make a major difference. Now, what I want to talk with you about, I'll go back to the home tab. Here, when you click the slab, by the time I click a slab, I choose it, it will see where I am. Why it's not letting me go back to solve, and I need to mesh again. It's actually to show mesh. Yeah. By the time I want to select the slab zones. Yeah. See, when I select now, I'm now able to select the slabs. Okay. So I think it's not why it's the mesh. The main slab is not kind of. I can select. It's not allowing you to select the main slab. It's only the voids. Now with the voids, let's work with the voids first. For whatever reason, the main slab is not closed. The main slab is not defined yet. But at this stage, let me just go to the voids and define them with a 0 thickness, just to get this out of my way. So basically, I'm selecting each void and defining its thickness to be 0. You can see here those 4 voids, they are with 0 thickness. This one as well, yeah, it is 0 thickness. Right, so we are good here, but surprisingly, I can't see the slab. So before I go anywhere and remesh it, let me have a look to the preview and see if currently you can see the voids are visible, but it looks everything is fine. Let's see what's going on here. And the voids here, they are all, I think it's all defined. Sometimes there are some pitches which for some reasons you won't be able unless you save the file. Make sure you're going to save, don't miss saving, and open it again. You will be able to clearly select, because I can see the voids are defined and the model seems to be okay. Let's click here. Let me save. Save. Just let me put it on. Okay. Now, just mesh it again. You can always mesh it again. Now, what I will do now, I will just show you how to close those gaps. So what you can do, click Tools, go to Fix Closed Nodes, and it will select current level, which is 1. We know it is the master. And they will ask you to select. I think I don't need to use this because I want to select to which thickness. All right. because it did not talk about nodes. So what I'm going to do, I will ask the software to round the decimals. The issue was with the decimals. And what I'm going to say there, if there is any error with 10 mil, to try to round it off. That was the error message I've read. So it was nothing to do with closing the gaps. If it did say that, I will use it here, but you can still do it, so it won't hurt. Say the current flow and say, okay, let's see if it's gonna tell us about any message. Say all the flows as well. Yes. Ground flow corners to ground. So it's only, yeah, there is no issues actually. There is no issues with the gap. The issue was with the rounding. If you read the message carefully, rounding. I will go, look, again, we here got very long building. So it's really won't affect the accuracy if you go to 100 mil even. If I change the size, in other words, if I change the size of the building by 100 mil or 10 centimeters, will it really matter? Not really. So for now, let's see if 50 mil gonna remove those errors we got. So we'll say, okay. And round geometry by 50 mil. Okay, so now we did the rounding and it will ask you to update the mesh. So now we can update it. And let me go with 0.5 meter or 75 update. So now it's remeshing. You can see there is no error anymore, so it's passed. It's going through without any error message, which was saying to us there is a rounding issue. There was no node issue. Maybe I clicked it carefully. Sometimes when I do it in a rush, there are gonna be some node placement issues, where then you can use this option here to fix it. But looks like the modeling was okay. And if you do it slowly, you're gonna have the same. So you can see there are no errors level by level. It's a bit slower than before because I've chosen 75.75 mesh size. Again, those mesh sizes, no mesh errors. They are all the finite element modeling we talked about in week 2. Basically, yeah, you can see it's very clean, nice meshing process. These are the elements. Total slab. So it's change. Yeah, that was so they telling us that we rounded off that 50 mil. Yes. Okay. Let's see if what happened. Why it's not showing me machine anymore? I'll do it again. I don't know what happened. I will do it again. 75 and run. Looks like it did not do what I asked him to do. Stop, exit. Tools. I'm just going to repeat what I did. Something happened at the end. I will just tell him to round 51. Okay. Yes. Maybe I said ignore what you changed, but I'm just doing it again. So what I was talking about is the meshing. Basically, you're dividing your piece of slab to smaller elements that will use the elastic theory and go through all the matrices that we have to define all the stress distributions for the slab. So again, I can see that it's smoothly cruising. Are there any questions? Is it going okay with you so far? So I don't know, maybe a vent asked me to ignore or do something about it. That's why it's kind of didn't do nothing, but let's read the message carefully. So basically what I did, I just chose a 0.75 mesh size, and I rounded the decimals by 50 mil. So all good here. I'll just hit exit, and now it's happy. Yeah, no issues. I suggest you guys to save always. Yeah. So we meshed and we saved, and here if you select, yeah, it's all as expected. That's what I mean. See, I meshed, and when I click on the slab, it will color it with this blue, and it's telling me it's 0.2 thick, which is what we agreed about. And you can see this is happening for all the floors. But now it won't allow you to select. Like if I go to level 4, 2, or 4, it won't select because we made that slave master business. Unless you remove it, you can always remove the slave master setup from tools. Once you remove it, you will have the freedom of selecting at any level. So now you only can go to level 1, and you can see if I select here, it's 0.2. If I select here, it's 0. And that's exactly what I expect. If I select this little gap, it's 0. There is a lot of nice options here. If, you can ask the software to show you by colors. So here, if it's a green, it means that it is, if it's a green shade, it is 200. So something different projects we may have different thicknesses, different steps, etc. So by now, the concrete elements, slab, columns, walls are set up. What we have to do now is place the loads. It's really easy. Placing the loads, dead load and live load. So let's assume dead load, the own weight is already calculated. You can see here, its dead load is automatically calculated, but we have to define the superimposed dead load, which was 1 kPa, and we have to define the live load. So to define the superimposed dead load, select dead load and make sure you are at level 1. Then go to home, select. One thing I want you to check before you select, there is a nice option where to allow you to put the pressure by clicking the slab, better than going through the ends of the slab and drawing it takes time. So what I do here, I go to settings, and I think it's under system. Let me double check. It's under system, yeah, uniformly distribute loading input, area load, say pressure load. Suggest you to use pressure load. Pressure load is easier. You don't need to draw the area of the load. You can just simply hit, and you can hit the green area. It will take the 1 kPa straight away. So just pay attention to this step here. What I'm asking you to do is before you define the loads, here you can see there's no option. So what you have to do when you select area, and you're going to define 1 kPa, you have to go click by click around the whole area, which is a lot of time. The best way to do it is we simply just click anywhere on the green zone, and it will take it as 1 kPa or live load as well. So what we do, click on settings, click on system, and then say not by area loads, by pressure loads. Click OK. No, we did not select any load, so don't worry. I don't want to undo. I think just OK. So now you can see if you go back to home, you have a pressure option, which is much more friendly, right? I don't know why they didn't do it as a default pressure, but that's how it is. So after we did this, click on pressure. Now put your 1 kPa, it's already there, and just simply click on that's it. So you can see this little one here. That means all the blue area is actually with 1 kPa, as easy as this. Now you have to change this to live load, and same thing, live load, I want to put 1.5, and it's already pressure. Look, 1.5 done. So you see, you got 1.5. You see, it's always small number here. 1.5 applied on the whole floor, live load, and dead load is applied all around. It's 1 kPa here, applied on the whole slab. So we're done. Dead load and live loads are defined. Now you're all going to ask me, what about the wind load? What about the earthquake load? Right. I'll show you how to do this. Now, what you do with that, so just say it again. What you do with that It's always a good idea if you reach to a milestone, save and then save as. So in case an error happen, the file is crashed, or sometimes the file is crashed and don't open again. So you have a backup. Like if you draw, especially the time you spend to draw the whole building, you don't need to keep repeating that. Sometimes I can tell you when you do frequency analysis, the software just don't get to the answer because there is some mistakes you did in some of the gaps, and the software don't want to really solve, or the model don't want to solve. Sometimes what we do, instead of investigating where was the error, we just carefully repeat it and it's just going to solve itself. Right, so now let me show you how we're going to define the lateral loads. And the way to do this, basically go to input. You have lateral loads here. Click on lateral loads and you're going to see the little table, which will help you to do everything. Now, first thing you need to do, okay, before you do everything, before actually we come to this window, you have to define all your cases. But I mean, first thing, define earthquake, wind load north, wind load south, wind load east, west. Then go to earthquake main, Y, earthquake, I think earthquake main Y, earthquake main X. Then after you define them here, you have to define the combinations as per what you did. So I will help you with that within the minutes we got there. And we'll show you how to apply. How to apply the loads is nothing to do with this main drawing anymore. We just need to work with tables. That's the easy thing. You don't need to apply the lateral loads from here. We don't do that. Lateral loads, we don't apply them from here. We basically use this tool under input, and we're just going to put them from this tool. So what we need to do here, define the load cases. Right, we already have the dead and live defined, so here I'm going to define, you use the good acronyms that will make it easy for the reviewer to check. So I will use, for example, north wind. We just call it north wind. I will call them south wind. I will call east wind. I will call west wind. And I will have earthquake X and earthquake Y. Now that 30%, I trust the software will deal with it, and that's what you're going to find out. Yeah, you come here and say this is wind, this is again wind, and this is wind, this is wind, this is seismic, and this is seismic. Now, some students are going to ask me, what we're going to do with the roof? Because we had a roof load as well. The way I will, okay, let me just say okay with all this. The way I will deal with it is, first of all, you have to remove the slave and master. Then I will go to the roof. And the way we can deal with it is reduce the thickness of the slab to an equivalent one. So, you know, in our roof, it again depends on what you did with your submission for part one. If you assumed your roof is concrete, then keep it as it is. If you assumed your roof, because we did that, the roof was 0.6 kPa, then change the thickness of that 200 concrete to an equivalent thickness that will give you 6 kPa, and that will do the job. All right, so just change the thickness of the concrete that we had at roof level to very thin, right? To a thin, instead of 200 thick, make it maybe 30 mil thick, something that will give you 0.6 kPa, and that's it. And then for the life load, come and change the 1.5 to 0.6. Okay, so I will leave that thing to be checked by you, because currently at roof you got 1.6, and I'm not until I remove the slave and master, I will be able to make the change. So yeah, I'm saying this again. Go back to the roof level, change the thickness of the slab to something that will give you an equivalent dead load of 0.6 kPa. And change the life load on the roof to be 0.6 as well. All right, and I will leave that to you. I can't do this now. I have to remove the slave and master business, but I don't want to do it now. I may need to use it. So what I did so far, I just defined the cases. Then simply go to, again, now load factors. This is something we're going to do later on. That's how you're going to define your combinations, and I will leave that to you. Remember the 10 cases, they have to be built from load factors, because that's what we're going to observe when we start looking, when you start comparing your stresses, 3D stresses, you're going to basically not look at dead load alone, not look at life load alone, not look at the pressures alone, I mean wind loads alone. You have to look at the combinations and just follow what you did for your assignment. Okay, that point now, where I leave that for you, for your team to do. We have this case already, so it's done for you. The 1.5G, 1.8, 1.5Q, 1.2G. This is, you can delete it. We don't have this case, so we use this for serviceability check, but for the vertical serviceability check, but you can delete it and start putting your case number 2 all the way to case number 10. Okay. For when you do this, you do it from this function, because when we do the analysis and start looking at results, the software will allow you to. It's going to come over here. You see, it's going to come here. When we see the results, you can see here. We already have the 8 cases, but they are the load cases. The combinations, they are here. Now we have only 2, so you can delete this and put your 10 cases, and then you will be able to see the stresses. That's what I asked you to do yesterday. Check stresses and check the frequency. Okay. So here, when I'm going to check your work, guys, I'm going to expect this to be updated correctly, and I'm going to expect, again, this is correct, which is almost correct here, but we'll leave that to you. So far, I've just defined load cases, and I showed you how to define load factors. The very last step I'm going to share with you is how to define, again, the earthquake load. The good thing, you don't need to calculate them to the software or give them to the software. They will calculate it. How? Click on lateral loads. Don't worry about dead load and life loads. North winds, click here. And we do have this handy tool, which will ask, you're going to be asking the software to adopt the standard. So select here and just put the options we had from, we used in structural toolkit. And I will leave that to you as well. So there were a couple of multiplier. I can tell you in your case, all those were 1. They were all 1. Okay, take them as all 1. Don't worry about it. Right, and this is take it 0. There is no extra height in the roof wind load. No, well, there is no extra. We didn't talk about this. So, and here, make sure you're going to select north. It is what? North is going to be along wind -y. Base level of the wind action going to be the ground. It is correct. And make sure you select this correctly. When we had the north, it was the negative direction, -y. Okay, make sure this option is correctly selected. I trust this one, A1 to A5, if you look at structural toolkit. So this is recorded, and the category, make sure we chosen the same, whatever we had in structural toolkit, because they will end up calculating those pressures. Remember the pressures you did in the tables? They will automatically calculate it and apply it on the building. Okay, so just look at your structural toolkit. What was the category chosen? I think it is 3, as far as I remember. It's in the tables. It is actually 3. And the region is between A1 to A5. Yes, that's correct. The rest should be 1. We did not change them. Well, if you're working in a real project, you can always check that. So that's basically what you're going to set up, because we have the north wind. And why north wind? Because that's what I'm looking at here, north wind. If you like, write it like with a clear text, don't use acronyms to make it clear for me to check. So if you're going to use what I'm using, I will know what you mean. But if you're going to use a different acronym, define it to me somewhere, or you can fully write it here. It's up to you. So I will hit OK. We're done. The software will all do all the calculations, and you can see they put the load here for you as well. So we're all done. They calculated the FY force. They are all negative coming down the page, and you don't need to worry about it. Same thing you do for the south. So in this case, click on use the standard. Just say it's +9, it's going up. The rest is same. Okay, so see how fast and easy it is. Yeah. And then go to the east. East is coming from left to right, so it will be plus X and hit OK. And west, it will be negative. I think this should be, the coding here is not really right. I can change it. You can always say OK. It's asking us vectority conformance. Okay, this is a parameter which we did not define. I think, yeah, we talked about earthquake, that's why it is not yet. Because I've selected it. Okay, so what does it do? What I'm trying to do here, I just wanted to fix this load case. This should be, you always can go and fix it. This should be west wind. Clicked there, just to make it look. So we said north wind, south wind, east wind, west wind. Click OK again. Now I go to electoral modes. Yeah, they are defined. The north is defined, the south is defined, the east is defined, the west we did not define it. Click here and say it is negative. Now it's happy. Yeah, west wind. Now earthquake with X, same thing. It will tell you use the standards, which is that's what we want to use. Yeah, so we click on the earthquake and just go through the process. Now, I just wanted to check if the software can automatically select the. No, it's not. So I thought it is actually going to consider the 30% by its own, but it seems to be not doing this. So you actually have to do it. You have to do it. You have to do it. So because what I defined here, in this case, what you have to do, let me cancel so we don't get confused. You have to define another two cases, which is 0.3x and 0.3y. Now, I know in your assignment, I asked you to do one case only, so do one case, that's fine. Do the cases you did in the assignment, part 1, which in your case, it was EX, the Y was full, and 30% of EX. So here, basically what you can do, go back here and just say this one, it's gonna be 30%. That's what you did with your calculations. 30% X and Y was full. And now we're gonna just follow what you did with your calculations, go back here, go back to earthquake. Let's do the full Y, because Y is coming down the page, it's coming up, down, that's what you did. So here I will do case number 8 first, click there, and that's YY, yeah. And look, don't worry about changing all those, leave them as they are. I think in your case, you just have this 0.9, that was clear. Load combination, here I trust you're gonna ask me, yeah, you would need to change it to the combination you had. So define another combination. Trust it was this one, but some students may have used 0.3 for the Q. That's fine, change it. I would say it was B, was it? Yes, it was B. And that's basically what you need to update. So this setup should be adequate. We're still following the static analysis, and here we go. It will define. Yeah, it's telling you. You may check this with what you got with your shear calculations. Right, this is the figure, which may be too close to what you had already. Okay. So I applied the forces from earthquake. Now 30%. 30%. Why? Let's go and see how it can be done. In this case, what you can do, you can actually apply the 30% here. So say 0.3G 0.5 of the G. So you have to introduce another case. You have to have case. I know here we're going to have your 10 cases, but because of this 30%, we will be required to introduce another case that will allow to the 30%. So you're going to say 0.3G and 30% of 6 is going to be 0.18, right? So you will, if you had 0.6, just 0.3 of that is going to be 0.18. And you need to introduce another case to allow for this 30% to happen. I originally thought the software going to do it for you, but seems not to be it. So definitely you need another case here. Say okay, and by now all your lateral loads are actually defined. Right. Let's see, is there a question? No. So far, we should be ready. We have defined the structure. We have defined the loadings, whether vertical loads, whether lateral loads, and after this, yeah, I think we all good. The loadings won't appear here. Run the analysis, go to solve, and click solve linear. And that should give you the stress calculations. Now, it will take time. I think my software is ready. I can click, but it's just going to take time to really go through it. Yeah, but it seems to be happy, just doing whatever it needs to do. And yeah, so it's just going through the process. But it will take time because it's going to go floor by floor. And even for the frequency analysis, it will actually need even more time to do. Anyway, that's really my briefing. I was trying to share with you. I trust some of you got classes. And is there any quick questions someone want to ask me about? But basically, that's the briefing I typically give the students. Feel free really to look at more other options and learn more from the videos. The videos, again, they are available in your LMS week. Which week was it? Week 3. We go quickly to week 3 DSD. Yeah, you're more than welcome to actually week 2. So it's week 2. There is training videos to be found here, which is very professional videos. And the good thing about it, if you want to learn something about analysis, frequency analysis, I said to you, we've got a special section about frequency analysis, which is just right frequency. It's here. Yeah, have a look to this video. And the good thing with these videos, if you want to only listen about frequency report, you click on it, it will take you straight away to that time. You don't need to watch the whole movie, the whole video. So it's very, very professional videos. And this video, yes, I strongly suggest you to go through it because you will need to make some setup, special setup for your software to let it do that.